So now we are going to see the same full wave AC to AC controller with RL load, RL resistive and inductive load. If the load have the inductor, then what will happen? It will be a little bit different. So here you can see everything else is the same. We are connecting two anti-parallel SCRs. So this is this direction and this one is in this direction. In the load side, instead of only resistor, we have the R and L combination. So we already studied about whenever we have the inductor, what will happen in the circuit, right? So if you do not remember, please try to recall. I will repeat now. So whenever, okay, now we are applying the AC signal. So during the positive half cycle, it will conduct or it will pass through this thyristor T1, right? Then the current will flow here. That is the IO. So this IO output current will pass through the load. When this output current is passing through this load, this inductor will start to store the energy in terms of magnetic field. That is the property of the inductor. You know, naturally we have the magnet. We know that maybe you played with these magnets when you were kids. But in this kind of magnet, this is called an electromagnet. It means whenever we pass the electricity, the current through some conductor, then this conductor will act like the magnet. So it will have some kind of magnetic field around that. So maybe next week I'm going to start discussing about EMFT, electromagnetic field theory. This is a very, very basic for all the motors. It can be AC motor or DC motor, how you can create the flux or the electromagnetic flux or electromagnetic force. How can you control the torque? The torque is controlling the rotation of the rotor. And when you change the frequency, how it affects the torque. So these things you should know that actually. Maybe you already study about this in your machines, electrical machines course, but I will touch some basic idea about this. I will try to give some physical demonstration if possible. Next, this magnetic field is working around the electro and also the natural magnet. Because here we are applying so many rules and laws, you know, we have the rules of thumb, we have the Fleming law and Faraday's law and so on. Now let's talk about this RL load. So whenever the current passing through the inductor, it's developing the magnetic field, and then current is fulfilling, reaching the source, and then it's completing the circuit. Then during the negative half cycle, of course, this one start to conduct already. Through this one, the current will start to flow. But because of this magnetic field, the magnetic field will start to discharge its charges immediately. So as a result, what will happen? So here you can see, I just forget this one. So I am starting the alpha here, maybe 30 degree is conducting, the positive half cycle is conducting up to pi 180 degree. Then the negative half cycle, of course, I start the alpha in the 30 degree here, pi plus alpha, because this is alpha and this is pi plus alpha. And in between this gap, there should not be any output voltage or output current, right? That is, it's supposed to be like that because I'm controlling the alpha value, the firing angle. But it won't be like that because of this magnetic field. Because of this magnetic field, there will be still some conduction here after pi. So this will be like this up to beta. So maybe it's 10 degree or 20 degree, we don't know. So it's depending upon the value of the inductor. So based on the inductor value, even though the positive half cycle is over, still there will be some conduction and there will be some current flow in the closed loop in the opposite direction. So here we will have some output voltage and output current. So this is just nothing but a firing angle. As I said, firing angle is nothing but a triggering angle. So this is alpha, you can see. So triggering angle means it's a large amplitude, short duration. Short duration means it's a very short time. Short duration, large amplitude. So Here I apply the trigger signal only at this point to the negative half cycle, but still I have some output voltage. So, okay, because of the inductor, this is the general property of the inductor. So this will repeat in all the half cycles. So this will happen in the positive half cycle, and it will also happen in the negative half cycle. So this inductor will discharge until the field to be collapsed completely, the electromagnetic field to be collapsed. So because of the inductor, voltage can go to the negative direction like this, negative direction until beta, but current will still be in the positive direction. That is the advantage. It means we will get continuous current while regenerative voltage due to inductance. So even though it's in this way, so you can see here, we will still have the continuous current. So it's not like we are cutting out the current between this gap or this interval. So we will get continuous current when we increase the inductance value. So if you increase the inductance value, of course, the magnetic field will be different. So the time to discharge will also take longer. So then the beta value will increase more and more towards this direction, Okay, this is the RL load, how the circuit works. And here is the formula for this RL load. So the same VO RMS, you have to apply the same formula, 1 divided by pi, because now we are going to make the average for each half cycle. So 1 divided by pi, 0 alpha to beta, because remember the limit I am applying here, it's not alpha to pi, alpha to beta, because the conduction is, I am starting the firing angle here, but the output current is up to beta, not ending here. So that is why the limit is alpha to beta. The input voltage is Vm sin omega t. I'm just squaring because it's a root mean square, and the whole power 1 divided by 2, it means square root. So if you apply this and if you simplify, this is the final formula for output voltage, RMS here. This is the output voltage, RMS value of the output voltage. So this is just a formula to remember. The RMS output voltage across the load can be varied by changing the triggering angle as usual. So by changing the triggering angle at different degree, you can change the alpha value. Based on the alpha value, you can change the output voltage. So this is called phase angle controlled AC to AC converters, or we can also call this a AC to AC voltage controller, converter or controller.